Welcome to the Python Learn Together, Code Together. Now we will see something about in-depth about the Python operators. Okay, because when we go in the next further videos, we need to thorough with all the operators in the Python. That means I already discussed some of the basic operators like a plus minus and some of the addition operators, all those things, in and not in, all those things. But now we will discuss that in one format way. That means there are lots of operators are there in Python, so we'll discuss all those things one by one. So now I will going to make the split screen of this. Here you can see we have mainly 7 operators. Python operator is called, okay. Arithmetic operator, relational operator, assignment operator, logical operator, membership, identity, and bitwise operators. These are all, that means different categories, and inside those categories mainly there are 7 categories, and inside those categories we have different kinds of operators. So I'm going to open my Python interpreter. We will going to see one by one all those things, operator, how it will going to work, everything. So here first one is the Python arithmetic operator, this one, okay. Python arithmetic operator. In that, addition operator. Addition means in order to add any two that means the quantities, or you can say any two data types like integer and the int or anything, okay. For example, first we will do all these things in one particular way. So I'm going to define one integer value, that is a equals to 10, and another integer value b equals to 9, okay. Then I'm going to define one string, that is c equals to, and here I need to define one string. I'm going to define this is say, okay, my string, and then I'm going to define one list, that is d equals to, and here I need to define one list, that is 1, 2, 3, 4. This is my list. And we already learned all those data types. So now if we discuss all these operator, then it will be better. So this is the list, and now I'm going to define equals to, we need to, and then tuple, that is equals to, okay, this has to be in parenthesis, or you can directly write these elements. So here I'm going to do 1, 2, 3, okay. Instead of 1, 2, 3, 4, I'm going to write 5, 6, 7, and 8, okay. Then I need to define something called, okay, this is the list and this is the tuple, and another thing we learned is the okay, list, tuple, and sets, okay. That is f equals to, and the set has to be enclosed in flower brackets, or you can use the set function. So here I'm going to define 9, 10, 11, and 12. And even when to define dictionary, that is g equals to, okay, dictionary I'm going to define okay, a is to, okay, a is to, yeah, instead of dit I will simply use the dict of, and inside this I need to this is a simple way. So a okay, a comma, no, a equals to 2 comma b, I will just write a equals to 1 and b equals to 2 comma c equals to 3 comma d equals to 4. Okay, this is the simple way of defining the dictionary. As I told you, all these data types are same that I told you in the previous video. I think yeah, these two are the integers, and this is the string, this is the list, and this is the tuple, this is the set, and this is the dictionary. Okay, now we will check the data type of all those things in order to clarify, in order to make sure these things are type, type of a. Okay, I will just going to use the print statement. Okay, yeah, yeah, we will just check type of a, and it is the class int, and type of b, and it is class int, and type of c, this is the class string, and type of d, it is a list, and type of e, that is the tuple, and E and the type of F. Okay, that is the set. This is the set, and type of G. Okay, type of G, it is the dictionary. Now we have all of the data types, that means the basic data types that is available in the Python. Now we will discuss all these operators by considering all these data types, how this operator will going to work. So first one is the addition operator. So for that, if I add a plus b, here it is the int, and here is also the int. Okay, just be careful about this. Okay, and I will just going to write those things in one notepad. A and b, this is the int. Okay, I think now it is visible, and C is the string, and D is the okay, D is the list, and E is the tuple. Okay, tuple, and F is the set, and G is the dictionary. Okay, just we will take this as a reference whenever we are writing something. Okay, I'm going to just keep this here. Okay, now a plus b. Okay, both these two are the int, so if I click then it will give us the int, the values in integer. Then I'm going to just use a plus c. That means yeah, now unsupported operand for plus, int and the string. That means we cannot able to directly add one integer with the and the string c. That is, so this plus operator cannot support the addition of a int with the string. And the next one is the a plus okay, a plus d. I'll check. Yeah, this is also not int and the list. We cannot add like that. So it requires a integer and the integer value in order to add. Okay. I think you hope understand about this. And if you come to the string, that means C is the string. I'm going to write C plus yeah, C plus C. These two, both two are the strings. If I click enter, then you can see my string and my string. That means two string we can able to add directly by using the plus operator. Okay. These two, C means here you can see it is the string, so we can add the two strings by using the plus operator. And the next one, D, that is the list. D plus D, I'm going to find D plus D, that is 1 2 3 4 1 2 3 4. That means we can add even the list. We can add two lists, one list to the another list. Okay, then E is the tuple, E plus E. Yeah, it will give us now 5 6 7 8 5 6 7 8. The list is mutable, I told, but the this one which is that tuple is immutable, but we can add two tuples. Okay, so this is possible to add the two tuples, as we can see, plus E. That means we cannot able to that means change that main E, tuple E. That means now for example, E equals to E plus E. I'm going to write like this, E equals to E plus E. Then yeah, I think I'm going to now redefine that tuple. You can see now this is we get redefined 5 6 7 8 5 6 7 8. It is get redefined. So we can do the redefined in the tuple. But here, since the tuple is immutable, we are not going to change. We are not able to change its elements. Here, these all elements here are added. This is because I just redefined here E equal to E plus C. But I cannot able to use this tuple as like E dot append like that. I cannot use like that. But in the list you can add the elements. Okay, so this is just a normal addition. That means if you add E plus C, it is going to do the normal addition. Okay, then we can just try with okay, E, then F is the set. We can do this F plus F. Okay, then in sets it is not going to support this F plus F, because as I told, in set, in order to add those two sets, it's called as the union. So we need to use and or operators, or okay, like A or B, A or A. Okay, not A. Here it is the set is going to F, so F or F. We need to just check F or F in order to add all those things. Okay, the addition operators which cannot be used in the sets. And next one is the dict operator. So G plus G, yeah, this is also not supported, because one dictionary which cannot be added with the another dictionary. Unsupported operand type plus dict is an dictionary. because if we add those two like that, then it will going to override all those dictionary keys. So it is not possible to use this addition operator in the dictionary. And we can check even like the mixed thing, that means int with a list or tuple with the set, anything we can check. And okay, for example, I'm going to just add e plus e is the tuple and I'm going to add with the set. It will give us the error because here you can see can only concatenate tuple, not set to the tuple. That means it is saying that it can be able to concatenate those two tuples. Two tuples can be concatenated, but we cannot able to concatenate the tuple with another things. Okay, for example, if I use dix comma dix is also not supported. So g, okay, I'm going to now add f plus c. That means this is also not supported. These two are the different data types, set and string. We cannot able to add those things. I think you have understand about this addition operator. Okay, then we will see the subtraction operator. Okay, for that I think you are familiar with all those things, A, B, C, D. What are all those things in A and B? Okay, A, B, C, D, E, and F and G. This one we just redefined, so I'm going to just change it again back to 5, 6, 7, 8. E equals to what is this? E is the tuple, so I'm just defining E equals to 5, 6, 7, 8. Okay, now all those values are like previous what we defined. So now we will check with the subtraction operator whether this subtraction is going to work on which are all the data types. Okay, now A minus B. Because A and B are the both integers, so it will going to make what's that, 10 minus 9, it will give us the result as 1. Then we can use just A minus C. Okay, one is the int and another one is the string. That's also not supported because it is showing unsupported operand type, because int and the string we cannot able to subtract that. Now we will just type C minus C. Okay, C minus C, that means the both of the string. Then if I click the enter, unsupported operand for string, because minus is not supported in the string, we cannot just able to subtract those two strings, but we can concatenate it by using the addition operator. So subtraction which cannot going to work on these strings. And next one is the list, so d minus d. Unsupported operand, that means we cannot able to even subtract the list. Okay, two list which cannot be able to subtract. I think we d plus d, this you can add. Two lists can be added by using two lists can be concatenated using this addition operator, but we cannot able to subtract the two list. And next comes after the list, it is the tuple, so e minus e. Then we'll see this also not supported for the tuple, and it is not supported. We can able to subtract in the set, as I told in the sets while explaining the set. As I told, the one set can be subtracted from the other set. So now here you can see f minus f, it will going to return the empty set. Here nothing is there, so we can use the subtraction in the set, but the addition of set is not possible, because in instead of this addition operator we need to union those two sets, because when it comes to the sets, so we are calling it as the union or intersection like that. So addition is not supported in the sets, but we can do subtraction of the sets. It is going to that means subtract the elements from if I write A minus B, then A, B are the sets, then it will going to write it will give us the output like the elements which are in A and which are not in B, like that. So it will going to A minus B, and it will give us the result. That is the so minus can be, or the subtraction can be used in the sets. Then if you go to the next dictionary, so G minus G. It is not unsupported operands type for minus. That means dictionary is not going to support you the minus things. That means if I minus two dictionaries, then it is not going to support it for it. Okay, and I think I even cannot able to it is not the D, it is the G plus G. As I told, this the addition and the subtractions, all these operations which we cannot implement for the dictionary, because the values, the key and the value, that means the key is unique. The key value is going to change if we make something on the dictionary. That means addition, all those things. That's why the addition and the subtraction is not supported on the dictionary. Then comes the multiplication. I can just A star, okay, A star B. It is going to give 90. This multiplication is supported, and A star, okay, A star C. That means we cannot able to multiply the string with okay, yeah, here it is the C. So here it is showing my, yeah, we can able to multiply. As I told in the some first video, it is going to give a star C, my string, my string, my string. That means how many times here the A value is 9 and C value is my string, so it is going to gives us the result as my string till 9 times. Here you can see it is the 1, okay, this is the 1 and this is the 2 and 3 4 5 6 7 8 9 times it is going to give. So for example, if I have anything like again I'm not going to show that means another string, and I think you hope understand about this. If we have any string, then if we multiply that string with any numbers, that means something called for example C equals to computer, then if I tell 3 times of C, then it will going to give computer like that. It will going to multiply that string 3 times and it will give us the result 3 times. Then if we check on this okay, D is the list, so I'm going to D star star and 2, okay. Then you can see it was not going to support that type error, unsupported operand type star star, or okay, yeah, it is not the star star, I need to just use the star. Okay, then you can see it is going to multiply instead of 4 I will give. Then you can see here the D is our list, that is 1 2 3 4. So here you can see 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. That means it is going to multiply that with the 4 times. So we can conclude that we can multiply the list. The list can be multiplied. So here we can see that yeah, we are going to multiply this list 4 times. Whatever the value we are going here, that times it will going to return the list which contains the elements that are multiplied with the 4 times. That means 1 2 3 4, this is my list, this list will be multiplied 4 times, so we'll get 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 inside the list. So we can say that the list can we can use the multiplication operator for the list. Then we'll go to the tuple. So okay, E and multiply with 5, okay, integer I will use. Yeah, even the tuple we can able to multiply that, but we are not changing the elements in the main tuple. That means E is our tuple, we are not going to change the elements in that tuple, but here we can use this E star 5. So it will give 5 times the 5 times it will going to print the whatever the tuples the elements which are inside this tuple. So here you can see it was going to return us the one tuple that contains the element 5 6 7 8 5 6 7 8 like that. It will going to give us the 5 times. So we can use the multiplication operator for even to get the multiple elements, that means multiple copy of the elements inside the tuple. Then if we yeah, I think if we check with E star of C, that means I'm going to multiply the tuple with some string. Then you can see it will going just to error, can't multiply sequence by non-int of type. That means sequence we need to multiply using the integer value. If it is other than the integer, then it is not able to multiply, so it will give us the error. Then yeah, the next one is the set F star and A. Okay, A is 9, yeah, but the set here you can see unsupported operand types for star, set and the int which cannot be multiplied. We cannot able to multiply that set, and we cannot okay, just I will check F star 4. That means the multiplication which will going to that means multiplication can be possible only with the integer, strings and list tuple, but it is not going to support for the sets. So in set the multiplication is not there. That means we cannot able to multiply and produce the elements like if you multiply one set, then it is not going to produce those many elements inside the set. Next comes the inside in the dictionary. If you use the multiplication operator, then we will see G star 4. Yeah, the dictionary also we cannot able to multiply, because in the dictionary all these keys are which are unique. So if you multiply, it will going to produce the copy, but that is not possible in the dictionary. So this multiplication operator is going to support only the integer, string, list, tuples. It will not going to support for the set and the dictionary. And next comes the division operator. Okay, so now A divided by B. Yeah, A divided by B. it is going us to return the float value a divided by b. A is integer and b is also the integer. If I have okay, a equals to our at the initial we have a equal to 9 and b equal to 10. Now I am going to just type a equal to 4 and b equal to 2. Okay, yeah, b equals to 2. Now if I do a divided by b, then it will always going us to gives the result in a float value 2.0. So yeah, again I will go to redefine that a and the b as to the original value. That means what the value we defined in the first. We can say that the division of the two integers always gives us the result in the float. Okay, float data type. Then if you go to next one, what's that? The string. Okay, c divided by 2. Okay, I'm going to divide, but the string which cannot be divided by any integer values. So I can try with c divided by c. That's also the wrong. That means string which cannot be divided by the string. String division is also not there, and string cannot be divided by those integer values. And next one is the d, that is the list. So d divided by 2. Yeah, this is also not possible. Okay, d divided by d, that is also not possible. That means list cannot be divided by the integer, or list cannot be divided directly by the string or anything, because it is meaningless. If we divide the list by the string, it's meaningless. So list cannot be able to divide like that. And next comes the tuple, e divided by 3. Okay, yeah, tuple also the same thing. We cannot able to divide the tuple by the integer value, and even tuple by the tuple. And next comes the f divided by 4. Yeah, this is also not supported. So we can conclude that yeah, we will check the dictionary too. Yeah, this is also not supported. G by g, no. So we can conclude that division operator is mainly going to work on the integer, and it will going us to gives the output in the float. It is not going to that means it's not going to support for strings, list, tuple, or set, or dictionary. It will going to only support the integer data type. And okay, next comes the exponential operator. It is a star star, so I will check a star star b. That means it is going to give us the exponential. That means a to the power b. So it will give us the value in integer. We will check what if a is in float. That means okay, I will going to define a as 12.1 and b equals to 2.3. Okay, 2.3. Then now I'm going to call a star star b. Yeah, we can see it will support even the float. That means if a and the b are in float, then a to the power b, it will gives us the answer in the float. That means whenever the answer is in float, it will give us in the float. Whenever it is in int, then it will give us the value in the int. Okay. Now, okay, I will going to redefine again a equals to 9 and b equals to 10. Okay. Yeah. Then the next comes it is after the integer, that is the string. So c star star. Okay, I'm going to c star star 2. Then you can see it will not going to support the power function. Actually, this star star is the power function. For example, it is showing that unsupported operand for star star or POW of this one. That means instead of in the integer we used to find the power, it is like 2 to the power 4, like that. Or I think we can just use this POW of 2, 4. I think yeah. That means we can use even this method in order to define the power, or in order to write the power. Instead of 2 star star 3, we can even use POW of whatever the number here we need to give, and the comma, and how much power it has to be raised. For example, 2 to 4 to the power 4. That means, yeah, you can see that it is called 256. We can use that POW, or you can use the star star. And the next one, yeah, the string does not going to support the power. You can check with the string yeah, that's also not going to support. Yeah, you can see the string and the string unsupported format for the power. then we can check even the for the list it was not going to support even that list, and d star star, that means because list to the power something is the meaningless. And next if we come to the tuple, then e star star 2, it's also not going to support, and even the set and even the dictionary also not going to support that. You can check that simply, but it is not going to support. You can see, and set, okay, this is my set, and that's also not going to support. So we can conclude that this one exponential is going to support only for the integer values. It cannot able to support the string values. And now we will see the floor division. Okay, for example, yeah, floor division, that is we can use the divider symbol 2 times. So for that a divided by b, that means it will going to give the result as 0. Because yeah, now b divided by a, then that is going to result as 1. We will just check a equals to 5 and b equals to 2. Okay, actually what is the answer of 5a divided by b? It is going us to result the value of 2.5. Now we will see what the a that means this floor division by b, it will going us to the value of 2. Okay, that means it is going us to gives us the only the integer value. It is not going to give the whatever the float value here. It will going us to give only the integer value. For example, if I have a equals to okay, a equals to 7 and b equals to okay, b equals to 3. Yeah, b equals to 2 we will take. Then we will check a divided by b. Yeah, it is again 3.5. Instead of that, I'm going to a equals to okay, a equals to 7 and b equals to 3. Now we will going to define a divided by b. It is 2.35. But now if we just check the floor division, a divided by b, it is going to give the 2. What happens if the float value is greater than 2.5 or 2.6 like that? So for that a equals to something 17 and b equals to 3, whether it will gives us the value greater than, yeah, it is now 5.66667. Now if we do the floor division for this, that means a divided by b, then it will going us to give the 5. It is not like it will going to approximate the value. It is not like that. It is going to gives us the only the integer value. It will going to exclude all these values which are after this decimal point. It will going us to give only this integer value. Okay, then we'll check whether this will going to support next one. What is that? Strings or for exponential. Since the division is not supported, I think floor division is also not going to support for any of the data types except this integer. We can check that yeah, instead of before that I will going to redefine my a and the b as to the previous value, and here c is my string, that is my string. Okay, floor division c, it was not going to give us unsupported operand type. And c divided by 2, yeah, it is not going to support for any of the data types. That means for even, okay, where is that data type list? Yeah, this the data type list, and it's not going to support for any of this data type. For example, g okay, floor division 4, it is not going to support for any of the data types. Okay, it will just support for the integer data types the floor division. This is the floor division. The next comes the modulus operator. Modulus means it is mainly used to get the remainder. Okay, remainder means we cannot able to use this modulus operator for the string and all. We will check what are all the data types can be used by using this modulus operator. For example, a modulus okay, where is that? A modulus b, it will going us to give the 9. That means a is equals to, here you can see a equal to 9 and b equal to 10. So a modulus b, that means 9 divided by 10, that will going us to remainder as 9. So it will going us to remainder as a modulus b is 9. For example, simply we can just check by a equals to 4 and b equals to 3. Now if we divide 4 divided by 3, and we will going to get 1 as the remainder. So that is the same thing this modulus will going to give. You can see the 1 as the remainder. What happened if a is in some floating point and b is equals to some floating point? Then we will check a modulus b. Then it will gives us the the modulus, that means the remainder in the float value. That means it is also same thing, whatever the result, whether it's in float or the int, depending upon that it will going us to gives us the result. Okay, so I'll just again redefine that equals to 9 and b equals to 10. Then if you come to the string c modulus c, yeah, it is not going to, not all arguments covered during the string formatting. If you use this I think yeah, c modulus 2, not all arguments converted during the string formatting. That means we cannot able to use this modulus operator to find the remainder in the string, because it is something not it is meaningless. So this modulus can be used in some formatting the string, that we will learn in the further sessions, how to format the strings. In that we will use this modulus operator inside the string. But here directly we cannot able to use this string as a c percentage that, or the c modulus of 2, like that. So this is all about, yeah, we will check this modulus with the list and all. So is my tuple e modulus 2, we'll check, yeah, it is also not supported, and f modulus 2, that is also not supported. So we can conclude that this modulus operator will going to mainly find that means the remainder in the integers. That means if the two values are integers, then we can use this modulus operator. This is all about the arithmetic operator in details. We checked what are all the values which are going to that means support for all these things. So in conclusion, the Python arithmetic operators, I made a small script. You can see that addition, which supports int float or int float. That means it can support the two values. It may be int or float or anything, and the string with the string, list, tuple, tuple, and subtraction int or float. And you can see that this is in summary what we have to understand. This I will don't worry, I will share this files along with the video for the reference. And next the next one is the, okay, this I will save it as something okay, I will save this as arithmetic. Okay, yeah, yeah, here this only I will, yeah, it is not arithmetic operators. Okay, yeah. Then we will come to see the next thing, that is what is that, our things, yeah, this is the completed arithmetic operators, and the next one is the relational operators. This were the relational operator, Python relational operators. Here you can see it is a less than, greater than, less than or equals to, equal and not equal, all those things. And we will discuss that one by one. And here, as I already taken in the previous video, I just redefined all these things in a fresh page. And here is our those things. A and B is int, C is string, D list is tuple, and F is set, and G is the dictionary. Okay, here also the same things. Now, okay, I will just split screen this, and yeah, this is not that file. Okay, yeah, this one. Now if we come to the Python relational operator, first one is the less than. Less than we can use to compare any two quantities, whether which is less than or greater than, like that, these two, less than or greater than, less than or equals to, greater than or equals to. That means if it will check for this relation, that means if for example here I am going to define A is less than B, it will check whether A is less than or B or not. If A is less than B, then it will give us the true, that means 1, or it is gives the true, or 0 means false. Okay, now we will check, it will give us the true. If A is greater than B, that is false, because here you can see A and the B. If I compare with something like C is less than A, I will going to compare the string with the integer, then it will give us the error, not supported between the instances of string and the integer. So it will going to support the same data. That means when comparing, we need to make sure that this type and this type are to be same data type, because less than and greater than, we can check that even for okay, if a is less than or equals to, I will going to now use this is the list. I'm going to just use the list. Then you can see it will not going to support that, but I can just d is greater than d, it is false. That means I can use this with that means we can use this less than or greater than operators with the list, or we'll check for the other thing, b is greater than b. Okay, yeah, this also false. That means we can use to compare two strings. For example, if I have I will just define x equals to and one string, that is hi, and y equals to hello. Then I can see that y is greater than x. Whether it's giving us true, yeah, it is true, because y has the more characters, so it will going us to, we can compare even strings with the strings. Make sure that both the sides, that means when comparing those two sides has the same data type. So we can, I think we can even compare the other data types like G is my dictionary and G is greater than G. Yeah, no, dictionary we cannot able to compare because not supported between the instantiate of a dictionary and dictionary. We cannot able to compare the dictionary. We will check for the tuple. For example, f is my tuple, because where is the table? Yeah, this is our table. We will just minimize this here, and yeah, now we will going to see the f. F means, yeah, it is the set. It is not the tuple, because as we defined it is the set. So f is greater than f. Yeah, we can even compare with the tuple because here these two are the tuples. So no, sorry, it is not the tuple, it is the set. So we can even compare with the set. If I have one set like a equals, I will going to just use x and y. X equals to, and here the set of a comma b comma c comma d. Yeah, I think yeah, that has to be in a single quote. So a comma b comma c comma d. And I'm going to define y equals to we'll check the type of x, make sure it is the set, and y equals to, and here I'm going to define another set of 1 comma 2 comma 3 comma 4. Now we will just check x is greater than y. Then you can see it is going to give us the false, because here I think x is greater than y. X is not greater, x is less than y. We will check what it will give. It is also false, because it will compare the number of elements inside this set. For example, if I have y equals to, I'm going to define 1 comma 2 comma 3 comma 4 comma 5 comma 6. Now I think we may get y is greater than x as 2. Yeah, it is false. Y is greater than x. We'll check what is this x. It is b, a, d, c, and y is 1, 2, 3, 4, 5, 6. On which parameter it is going to check, we will see x is greater than y. It is also false, and x is less than y. That's also false. That means, we'll check x equals to y, and x is not equals to y. Yeah, no, sorry, x is not equals to y. Yeah, this is true, because these two are not equal. But when we check x is less than y and x is greater than y, it is going us to give us the false in both the situations. Because we have to make sure that here inside this is a character, but here it is the int. So I think we cannot able to compare like that, because one set which is containing the integer values and another set which is containing the character values, if we compare by using x is greater than y and something like that, then it will going us to give us the false. Always it will going us to greater than or less than anything. If we check, so it will gives us the false, because it will always return us the value 0 if those two things, that means x and the y have different data types inside it, then it will going us to give us the false. Therefore while comparing those two sets, it will not give us the appropriate result if our data type is different. We'll check for what if the data type is same. I'm going to define my set as 1 comma 2 comma 3 comma 4 comma 5. Okay, then another set as y equals to 1 comma 2 comma 3 comma 4. Okay, now if I check y is greater than x, then it will give us the false, and x is greater than y. Yeah, it is true. So we can conclude from this situation that when I check for x is greater than y, because x contains the more elements in the set, so it is going us to give true. But in the previous case, when these two b, a, d, c, this is the character type and here it is the integer type, at that time it is not going to give us the appropriate answer because it is always gives us the false. So make sure that while comparing the set, both two sets contains the similar kind of data types. And yeah, next we will check these things with that means lesser than and greater than with the tuple, that is E is my tuple. So E is greater than E, it is going us to give false. That means we can even compare the same as like this, similar to this the sets, we can even compare the tuple. For example, I'm going to define x equals to, this is my tuple 1 2 3 4 and y equals to 1 2 3 4 5. Okay, now if I check y is greater than x, it is going us to give the true. That means you can just check the type of x and it is the tuple. Okay, so from this we can conclude that this greater than or less than, that will going to operate even on, that means we can use that even on the tuples. But make sure that this tuple elements has to be same, I think, because here if I have x equals to and tuple elements like e comma e comma f comma j. Okay, now if we come, yeah, it is the invalid syntax. Yeah, we cannot able to create the tuple like that, but instead of that we need to use we need to use like the normal brackets in order to create the tuple. And here I'm going to create hi and here I'm going to create another hello. Okay, now we will check. Now if we check the type of x, then we can see it is class tuple. So now we have x is hi and hello and y is 1 2 3 4 5. Now if we compare x is greater than y, yeah, it is not going it will just gives us that type error, greater than not supported between instances of string and int. Okay, that means here these two, that means this is the class tuple. Okay, x is the, we can check the type of x and type of y. You can see both these two are the tuples, but when we check x is greater than y, then it will going to gives us the error as not supported between the instances of string and the int, because it is not going to check in. If we take the tuple, then what it will going to do means it will just take the one from here and that means here it is the string, so it is giving this as a string, and here it will going, these are all this in a integer, so it will going us to give this, there is no support between the string and the integer. I think you have understand about if we have the tuples which contains the different data types, then it will gives us like errors such like this. It has a different data type, so it cannot be able to compare by using this relational operator greater than or less than. Similarly, we can use this less than or equals to, greater than or equal to. It is exactly similar to the less than or equals to, but a change is that it will even include the equal. That means less than or equal or greater than or equal. For example, now I have a equals to 9 and b equal to 10. I can just now for the time being I will going to redefine this a as 10. Now if I just tan a is greater than or equals to 10, then you can see it will give us the true, because a is equals to 10. It will going to check whether it is equal or it is greater than. Depending upon that, it will give us the true or the false values. So again I'm going to redefine that a equals to 9. I think you hope understand about these things, greater than or equal to and less than or equals to, and equal to and not equal to. That means if anything, for example x equals to 10 and y equals to 10. So if I check x equals to y, if it is a x and y are equal, then it will gives us the result as true. Okay, then if it is not equal, that means x is not equals to y, but here x is equals to y, that means so it gives us the false. It will just check whether the value is equal or not equal, these two symbols. I think you hope understand about the relational operator. And okay, in summary we can say the like yeah, this is what the summary we can learn from this lesson. Greater than, it will support I wrote all the data types. It will going to support all these relational operators. And yeah, we will say this. I will make sure that it will going to provide in the download list. And here, yeah, I'm going to say this as Python relational operator. Okay. Then the next operator, that is okay, we will just open that. The next operator is yeah, this I'm going to reopen those things, Python IDE. And okay, the next one is the assignment operator. Yeah, we will just open the Python interpreter. And okay, here we need to just open this. Yeah, this is the Python assignment operator. Okay, that means equal, plus or equal, and yeah, plus or equal, and minus equal, divided by equal. These are the sum of the assignment operators. So here, yeah, I just forget to define all those things, A, B, C, D, F, G, H, and I will define that now. Okay. Yeah, I defined all these things, A, B, C, D, F, G, as shown like this. Okay, here A, B is the int, C is the string, D is the list. Yeah, same to the previous things. Then now if we come to the Python assignment operator, the first one is the assign operator. That means equal. For example, this like yeah, this is, I think you know, because we assigned already lots of variables to the list or integers like that. Here only it is called as the assignment operator. A equals to 10, that means A is assigned to some value. For example, if I assign, if I just click X and if I click enter, then it will give us a name. X is not defined, so now I'm going to define X equals to something. Okay, X equals to 10. Now if I click the X, then X equals to 10. That means this is called as the assigning operator, equals. Then next one is the plus and equal. Okay, just you can see that this is the plus and equal. That means it is the add and assign. That means it is going to add and that it is going to assign that. For example, I'm going to just use that x okay, yeah, x plus equals to 10. That means, okay, now if I click the enter, now if I check the value of x, it is going to 20. That means x is x plus equal, it is going to add that. X plus means it is going to add x. That means okay, now for example, I will just go with another example. A is equals to 10. Okay, A is equals to 10. Now if I call A equals to A plus 10. Okay, what is that? A is equals to A is 10, 10 plus 10. So now A is assigned to 20. So instead of this statement, okay, now if we check the value of A, it is going to 20. Okay, now I will again going to assign equal to 10. Now if we just tried A plus equals to 10, then it will going to add and assign. That means it will going to add. For the A, it will going to add 10. Now A equals to 10, so 10 plus 10 is equal to 20, and it will going to assign that 20 to the A. Okay, similarly the subtract. Okay, this is the same thing. Now if we check the value, it's going to 20. Similarly the subtractings A minus and equals to 10. So now you can see, check the value of A, it is equals to 10. And divide and assign. That means first it is going to divide. For example, A divided by okay, divide. Okay, A divide equals to 2. Okay, now if I check the value of A, then it's equals to 5.0. That means before that A is equals to 10, then it will going to divide that by 2. That means 10 divided by 2, that is the 5.0, because division always gives us the values in the float. It is 5.0. Then that 5.0 will be assigned to the variable A. So it is called as the divide and equal. It will going to divide this first by using the whatever the value we are giving here, and it will divide that, and the result that will be assigned to that variable. Similarly, you can understand all those things. That means the multiply and assign. It will going to multiply first, then it will going to assign, and the modulus and assign. It will going to find the modulus, then it will going to assign. For example, if I have A equals to, okay, A equals to 10. Okay, then A mod equals to 2. Okay, 3 means it will give us the result as 1, but we will check what it will give. Now you can see A is assigned with the value 1. If we just make 10 mod 3, then it will give us the result as 1. Here also the same thing will happen, but this result will be assigned to that A, because here we use the equal symbol. So it is the divide and assign, multiply and assign, and yeah, modulus and assign. Okay, this is, yeah, sorry if I tell this as a divide, it is the modulus, and next one is the exponential assign, and floor divide and assigned. It is similar to the same things. That means it is similar to this arithmetic operators. You can see all those things are same, but it will do all these operations, arithmetic operations. Then the special thing what is added is the equal symbol. Just we use the equal symbol after the arithmetic operations, so that becomes the assignment operator. That's it. There is no any change. It will do the same operation as the arithmetic operator, and then it will going to assign those values to the variable. That's called as the Python assignment operator. The things that we checked by using the different data types, that means those for arithmetic operator we checked using tuples, dictionaries, all those things. So that will be going to for the same things. Okay, that is also holds good on this assignment operator. But here we are not only checking, so make sure that there is one variable before using this assignment operator. For example, if we just write something equals to 3, then it will go to the wrong syntax error, because make sure that some variable is there before using this assignment operator, because we are assigning something to here, some operations are did, and we are assigning that to something variables. So make sure that the variable is there. And the next one comes to the Python logical operators. Okay, I think you are clear with this assignment operator. Next one comes the logical operator. Logical means it is here you can see the truth table of this logical operator. The logical operator is mainly by using AND operator, OR operator, and the NOT operator. Okay, here there is no any special symbols for these things. AND operator, or in a logical operator there is no any special symbols. We need to just type AND or 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 NOT, like that. We need to use like that. For example, if I'm going to define that as x equals to I will just define as x equals to 0 and y equals to 1. Then here you can see the AND operator. AND, okay, it will going to AND of in electronics we learn that how the AND gate or OR gate and the NOT gate is going to work. NOT gate means it is going to just not of that. That means if a is equals to 1, then we are going to make 0. If it is 0, then it is going to 1. OR gate means here I already wrote the truth table. You can just see is 0 0, then it will use the 0. Okay, it is like this. It will follow this truth table of AND or the OR gates. Okay, AND means it is the multiplication. Here you can see 1 and the 0 gets multiplied, and the resulting will be 0. Here 1 and the 1 gets multiplied 1. That is the AND gate. Okay, OR gate means it is just like addition. So 0 0 it is going to give 0, 0 1 it is 1. Anything which is greater than 0, that is going to give us a 1 in OR gate. So for example, here 1 and 1 in binary it is equals to 1 0. So 1 0 means it is equals greater than 1. That means 1 0 means the value is 2. So it is given this as a 1. This is about the OR. So we can use the like that x and y. Okay, now you can see it is going us to 0, because x is 0 and y is 1. X is 0 here. Okay, instead of a b, just make sure that it's x and y. X is 0 and y is 1. So the resulting x and y, here we can see that it is equal to 0. So it is going to give us the 0. Similarly, we can use even the OR. For example, yeah, we can use the A. Okay, I will just go with A equals to 1 and B equal to 9. Okay, then if we do the A and B, okay, it is 9. A and B, it is going to give us as the 9, because here you can see A is equals to okay, yeah, here A equals to 1 and B is equals to, yeah, here B equal to 9. I think now we are getting confused a little bit. I will show you something. Okay, as I told, it will going to gives the result based on this table. So I'm going to write, okay, here A equals to, okay, A equals to 10 and b equals to something 5. Okay, now I'm going to write a and b. Now you can see it is going to give us the result as 5, but in the previous, okay, previous a is 1 and b is equals to 9. That means b is greater. We may think like that, b is greater, so it will gives us a and b as b, answer as b. But here you can see, carefully observe this, okay, carefully observe these things, and just I will go to define a equals to 1 and b equals to, yeah, the same thing, 9. Now if I do a and b, it will going to give us the value as 9. Okay, a equal to 10, b equal to 5, so a and b is 5, the b value, and a equals to 1 and b equal to 9, a and b is 9. That means we may think we are getting always the b value. When this 1 and 9, it will get 1 and 1 means here you can see it is 1. Okay, so we may think we will get always the b value. So now I'm going to define a equal to 0 and b equals to 9. Then we may check a and b. It is 0. So the main thing is that inside the table, instead of input, we will correct that to input statement. ENT. It is input statement. Okay. Then this is the output. We may correct a little bit like that, because actually the logical operator means it is not just taking the input as 0 and 1 and we are assigning. It is not like that. The logical operator means it is going to calculate the some expression here. For example, if I have some expressions like 3 plus 4, okay, 3 plus 4, and here I'm going to use and 2 plus 3. That means here what it is going to do means it will going to calculate this expression, that is 4 plus 3, that is 7. 7 is true. Okay, 7 is true means this will leave this case, because here this is not there and this case is not there, because true. So 1 and 1. Okay, then it will going to calculate this 3 plus 2, that is 5, that is also true. So this 1 means 1 and 1, that is also true. Okay, so now it will return us the 1. That means the what, okay, now if we click the enter, it will going to return us the 5. 3 plus 2 is 5 and 4 plus 3 is 7. We may think why it is not giving a 7, why it is giving 3 plus 5, that is 3 plus 2, that is 5. It is because, carefully now see what I'm going to tell. First of all, this operators here in logical operator, inside this logical operator section, when we use this AND operator or OR operator, anything, for example, if we use the AND operator, then it will going to check the expression what we are giving. We need to use this AND operator in comparing two expressions. Here is one expression and here is one expression. Or if we give the value like this, then that value is the result of the some expressions. We are thinking that that value is the result of some expressions. Any value which is greater than or equal to 1, that is treated as 1. Any value which is equal to 0, that is treated as a false or a 0. So if we normally we use this logical operators in comparing with two, that means two expressions. So here there are two expressions and in between we are using this logical operator. What it will do means it will going to compare the expression 1, that is here, okay, your side is expression 1 and here is the expression 2. It will going to calculate the result of that expression, and if it is false, okay, if it is false, here you can see if it is false, then it will directly gives the output of that complete expression as false. For example, if I use here something 3 minus 3 and 4 plus 4. Now this AND will going to calculate, first of all it will going to calculate this expression. If it is 0, if it is false, then directly it will gives us the output as a false. It will not going to check this, because here we can see if it is 0 and this is also 0, that means the first operator is 0, the first expression is 0, then always the result is 0 0. So it will not going to calculate this, so directly it will gives us the answer as directly it will going answer as 0, you can see here. But in case if the first expression is true, here what I'm going to write means 3 and 4 plus 4. Now the first expression is true, so it is not going to directly give that as true, because if the first expression is true, then there are two possibilities. The second expression may be false or may be true. So it will check the second expression. Here 4 plus 4. 4 plus 4 is what is that? 4 plus 4 is true. So now this condition met. So this will return this value. That means here 4 plus 4, it will return us the 8. You can see now it will return us the 8. Instead of 3, because 3 is it is 1. Okay, here this is the first expression. First expression is 3, and it will going to, if the first expression is true, then in the AND statement you can see here it is going to calculate the second expression, and if the second expression is false, then it will directly gives us that 0. That means the second expression, that means 0. Second expression is always 0. And here if the second expression is true, it will going us to a result of that second expression. So here we can see if anything expression is there like 4 and 0, then we can say that 4 is the first expression, that is true. So it will go to check the second expression, that is 0. Then here you can see the first expression is true, then the second expression is 0. So it will directly gives us the 0. But if we check like 4 and 6, then it will going us to give us this 6 as the answer. You can see 6 as the answer. Similarly, when we come to the OR operator, OR logical operator, here we have the table 0 and 0. If the first expression is 0, then the second, depending upon the second expression, it may be the output may be 0 or 1. 0 or 1. But if the first expression is going to true, then always the result is true, because here you can see the true in OR operator. That means if the first expression, for example, if I use not here, here, if I use here first expression is true 5 OR, then whatever I'm going to write here 0 or 1, 0, or we can write even 6, 5 or 6, then also it is going us to gives us this 5 as the output, because it is not checking the second expression, because not need of necessary of checking the second expression, because here we can see if the input is 1, the first expression is resulting input, the resulting output of the first expression is 1, then here we can see it is always the output is 1. If it is 0, for example, I'm using a 5 minus 5, or directly we can use 0, or then it will going to calculate the second expression. Here something 4 plus 4, then it will gives us the value as 8. Or else I can use 0 or 0. Now this 0 is actually all zeros are same, but this 0 is because of this. That means this is the first expression is 0, so it will going to calculate the next expression, and it calculates this one, that resulting it will show here. I think you've understand about this and and OR operators, logical operators. There is another type of operator is there, that is also called as the and OR operator, but it is in a bitwise operator section that we will see in the later in this video. So here this is the logical operator, and not means I think you hope understand for I need to use this is like it will take only the one value as the input, that means not of 6, not of 5, then it will going just to give as false, because it will just return true or false, because here not of 5 means any value which is greater than or equals to 1 is always 1, so not of 1 means it is 0. So we can use even to just to check many expressions. I will just call this as a not of true, that is false, and not of not of false, not of false. Then you can see it is true. Okay, like this, any such big expressions are there here, it will going to calculate that and it will just reverse the true or false result. Okay, that is what the logical operator. And I think this don't confuse with this table. It is like if it is 0 0 then it will give 0, if it is 1 1 then it's like 1. That's not like that. If the expression, if the output of that expression, depending upon that expression, it will going to give us the output. If this is 9 then it is true. If for example if it is 9, then if you use in the AND operator, if it is 9 the first expression, then it will going to calculate the next expression. If this expression is 5, then it will go us to gives the result as 5 in the AND operations, like that. I think I hope understand about this. Here this has to be 1 and 1 and here 1. Then next one is the Python membership operator, that is the in and not in. I think this I have explained in the earlier video. The Python membership operator is like if we have anything like okay, I will going to just check like one. Okay, we have C is my string. I think I can use something like here I'm going to define character D. No, I will just use Y in C. We'll check whether it will gives us Y is there in my string. That's why this character, that's why it will gives us as the true. And we will check this in and not in operators, that is it is called as the membership operator, that we will check whether it's applicable for the sets and all those things. And here I think I have these things. So here I'm going to check whether okay, my set is it has 9 10 11 12. So now I'm going to check whether 10 in F, okay, it is true. And we can use this membership operator inside this set, and I think in tuple also we can use phi in E. Okay, then similarly the not in is the exact reverse operation of this in. Okay, if we can check if phi not in not in E, then it will going to return as the false, because phi is there. It is the opposite of that. Okay, now we can see our dictionary, and we can just check whether A, okay, it is the character A in G. We will check, it is true. We need to give the key. Now we will give us the value, then we will check 2 in G. Then it will going to give us the false, because we can use this in and not in operators in the dictionary in order to check whether the key is there or not. Because if we understand whether this key is there, then we can retrieve that values. So by using this membership operator, we can even in the dictionary, it is very helpful because in order to check whether the any before adding or anything to the dictionary, we can check whether it is there or not. For example, your contact list, that is similar a kind of a dictionary. All the names are there. When we just click on the search bar, it will going to check in Android. It is not going to like that, but if you implement that contact list in the Python, then we can say like when we search something names in that search bar, it will going to check whether it is in or not. If it is there, then it will going to display that. That way we can create our own contact list by using this dictionary contact list application. Okay, just computer application, we can create like that. That is the membership operator. Then the next one is the identity operator. I already properly explained about this identity operator. It is something different, because we may think like 4 is 4. That means we can easily think like identity operator is same as equals to operator, double equal operator, but it is not like that. Oh, it is is something, not a 4. Syntax warning, is with a literal. Did you mean equal? It is now it is going with is with the something literal. It is a warning, not it is the error, but it will return as the true. Okay, the result as a true. in Python official interpreter, it will asking something syntax warning. It is because, as I already told, if you want to compare the numbers, then we can just use 4 double equal. This is the batch operator. If you want to compare in and not, that means this is and is not identity operators. They are actually used in order to check whether those two are came from same object. That means in previous video I just drawed one something like boxes and from this root. For example, if I have a variable a equals to 10 and b equals to 10. Okay, now if we check like this, it will not going to give us the error or any warning. A is b, then you can see it is true. We may think that it is similar to this equal, but when we use the very huge number like a equals to 1000 and b equals to 234, then a is b. We will check it is false. Yeah, it is false, but yeah, b equals to 1000. Now if I check a is b, it is also false, but we can see a equals to 1000, b equal to 1000. As I told, it is not going to after the value 256 from something -5 to 256, it is going to give us the result like same as a double equal operator, but after the value 256 it is not like that. It is just by comparing. It is that means when we define any variable, it will check that ID. As I told in that previous video, just refer that video where I explained very properly. It will going to check the ID of yeah, I think yeah, I need to just yeah, ID of a. Okay, I'm going to check the ID of a, and it is 16 something this, and ID of b, then it is different. We can see it is 84 and it is 44. Therefore it is going us to give us as a false. It is mainly it is going to compare those IDs. Okay, then if these IDs are same, means those two are origined from the same, so it will give us as the true. If it is different, means they have the different objects in order to assign that value, so it is going us to gives us the answer as false. That is the main word, this identity operator, is or is not. And next one is the bitwise operator. This is important. It will going to, this bitwise operator is mainly we will use in the binary operations. Okay, mainly it will use in binary operations, and we can understand it by using some binary numbers. For example, I'm going to define a equals to 1001, that is 9. Okay, but here it will not going to take this as binary. So what we can do means a equals to 9 and b equals to 10. Okay, I will just strike this. So here we will just strike 9 is 1001 and 10 is 1010. That is the binary equivalent. If we do the binary AND, okay, it is just a we are not going to write a and d here. In the bitwise operator we need to write AND like this one symbol. This is the OR symbol, it's the Xor, and it is the ones complement, and it is the left shift and the right shift. Okay, here if you want to find a and okay, and symbol a and b, we can see the result is 8. How we get this means, this is what the 9 value in binary and this is the 10 in binary. Okay, then it will be finding. Okay, now the answer, how it will going to find means it will take the each bit. That means it will take this one the bit 1 from this and this bit, and then this bit and this bit, then it will going to do the AND operations on each separate bits. So for example here, okay, I will going to show you one small picture of that. Okay, now yeah, now here we can see 1 and 1. Okay, now it is going, since we use the AND operator, it will perform the AND operation on each bit of our number. Okay, that will convert to binary and it will do the operations. For example here 1 and 1, here we can see 1 and 1 is equals to 1. If any other things, then it will going to 0. So here it is a 1. Okay, then 0 and 0, that is 0. Then 0 and 1, that is 0. Then 1 and 0, that is also 0. So 1 0 0 0. 1000 in binary is equals to 8 in decimal, because here 2 power 0, 2 power 1, 2 power 2 and 2 power 3. 2 power 3 is 2 to the 4, 4 to the 6. No, yeah, 4 to the 8. Yes, sorry, 4 to the 8. So here it will give us that 8 as the answer. So we can see that here we can see that the same answer. This is what in Python it will going to bitwise. Okay, then similarly if you use the OR operator, then it will perform the OR operations on each things. For example, A or, okay, not this OR, we need to use that pipe symbol. Okay, yeah, A or B, then we will get the value as 11. Because here we can see by this image, okay, now this is what the AND operations, and in the OR operations 1001 and 1010, okay, 1010, and in the OR operations it was going to, okay, 1 and 1 and on, the OR is equals to 1. Okay, so here it will going to give us the 1, and 0 is 0, and this is 1 and this is 1. Here we can see this value is this is equals to 1, and this is equals to 2, 2, 3, and here it is 8, 8, 9, 10, and so here we get the value as 11, because here 2 power 0 is 1 and 2 power 1 is 1, that is 2 plus 1 is 3, and here it is 8, 8 plus 3 is 11. So it will give us the value as 11. Then similarly the XOR operator, A XOR, that is A XOR B, that is the shift 6, okay, for this A XOR B. Then if I use this we can see that the answer is 3. Similarly, when we check this table, same thing what we did for here, the XOR table, it is XOR. Okay, here the some mistake is there, we can call this as XOR or EXOR. Okay, so depending upon this table, here I'm going to get 1 and 1, that is 1 and 1, 1 XOR 1, that is equals to 0. So it is 0. Okay, here I'm going to write that the XOR value is 1, and XOR 1, that is the value is 0, and 0 0, that is 0, and is 1 and is 1. So here we may see we are getting the 3. So this is equals to 3. This is the XOR value. Okay, XOR value. And similarly okay, once complement, that is we can use by using shift and this symbol. Okay, yeah, shift and that this in laptops it is just like a left side of this one. Okay, shift and this symbol. So we can do like A and once complement B. Then you can see, yeah, syntax invalid syntax. Why? Yeah, once complement means we are not using two variables. We need to just use once complement of A. Then you can see it is minus 10. Here there is no any 2 in ones complement. We are not using 2 because we can just type ones complement of something is like that. It will going to reverse this. If it is a for example, yeah, I have this as 1001. Okay, now what it will going to do means 0110. Then but we may get confused by seeing this, because we will check once again what is our value of A. A is equals to 9. Now I'm going to just make the ones complement of A. Okay, but it is giving minus 10. Initially I thought it is something, it is giving the wrong answer. But okay, we will check that it is the 9. Okay, where is, yeah, not this one. Yeah, here we will just define, I think, yeah, some more are there. Yeah, here 1001, it is the value of 9. So if we find the ones complement of this, that is 0110. Okay, but here we can see the value of this ones complement is equals to 2 power 0, and here is 2 power 1 and 2 power 2. So it is equals to 6. That is 0110. That's equals to 6, because here it is 4 and it's by 6. But here we are getting minus 10. Then what is the meaning of this? For example, A equals to 2. I will define A equals to 2. Now 2 is equals to, in binary it is 1 0 not 10, it is 0010. Okay, I will just represent that in 4-bit format. Okay, or I will just represent that in 8-bit format, because in computer it will going to represent that in a like 1 bit means 1 byte means it is equals to 8 bits. So I just took the 8-bit format. Now this is equals to 2, but if we complement this, then we may get like 1111 and 1101. This is the complement, that means the A's complement. But when we check the value of complement of A, then we can see it is equals to -3. Okay, how we get this means it is equals to -3, but here we can think it will never it will give you the -3 value. The main reason is that in computer the negative values, that means the -2 or -3 or any negative values, that is going to store in the 2's complement form. In the computer, the minus value, or in and this processor or is RAM, ROM, in mobile also these things applicable. Okay, the negative values that will going to store in the 2's complement form. So what happened means here the 2's the value is equals to, we can see that it is equals to 00000010. Then 1's complement, it will become 1111 and 1101. But when we convert this to 2's complement, because the computer has to save this value in the 2's complement form, so it is going to save that in 2's complement form. So 2's complement is equals to 1's complement plus 1. So I'm adding 1 to this, so it will becomes 1111. And okay, here if I add okay, yeah, here I need to add 1 for this. Then yeah, 2's complement is equals to 1's complement. That is, if we complement this, then we will get this answer, 1's complement plus 1. That form we need to add 1 to get the 2's complement. So here the 1 is added. Then okay, yeah, here we need to add 1's to get the 2's complement. So this becomes not 110, it is same equal to this one, that is just I confused, but it is not like that. Here it has to be okay, 1 1 and here 0. Yeah, it is 0. Okay, so now we may say that add 1 to get the 2's complement. So here if we added the 1 for this one, then we will going to get 1111 and 1110. Okay, now we get this as 110. Then yeah, okay, now this is the actually 2's complement form of the number, that is 2. This is the 2's complement of our number, that is 2 equals to, okay, I'm going here A equals to 2. I'm going to calculate the 2's complement, that means the 1's complement of A. But I told that the answer is stored in that means the 2's complement form. So the answer is -3. How we get means okay, now we got this as the 2's complement of this the value, that is A equals to 2 as 1111 and 1110. Then this is the actual answer we need to get. In 2's complement we may call this as the MSB bit, that is going to represent here the what is the value of this, it is 2 power 0, 2 power 1 and this 2 power 2. That means now it is going to represent now we get this as 1111 and 1110. I think I confused you a lot, sorry for that. And now here the 1111, this will going to represent, okay, this will going to represent the negative. Okay, in 2's complement it will going just to represent the negative, the MSB bit. Then I downloaded one small table for that. You can compare with the number with this. Okay, here this is the number table, that means how in computer the number is going to save. So here we have 1 1. Okay, here yeah, 1's complement of this is 1111 and 1110. Then in the 2's complement we get like 1111 and 1110. We need to here already I provided the table. So here it is yeah, I just got confused and I searched in Stack Overflow about this. The main thing what we can see that here we are finding the 2's complement. Here we have the 2 and we find its 1's complement, and now we find its 2's complement, but it is not at all matching with this answer -3. Okay, here we can see, but here we can see we are getting the complement of a is equals to -3, 1's complement. But I searched somewhere and it told us that the negative answer that will be stored in the 2's complement. So we find it the 2's complement, but here the answer is -3. It is not matching with this. So okay, -3 is equal to 1101, but here it is 1110. In computer, what happened means this number will going to that means here if we type the complement of 2, then this number will going to save. Yeah, theoretically it is right, 1111 and 1110. Even in computer this number will going to save. But why it is showing here -3? It is because when we convert this number to the decimal, here it is showing in decimal form. Actually the 1's complement of a, that is equals to this answer. Okay, but the computer store this answer, since this answer is in negative, this 1's complement is in negative, because here we can see it is 1111 and 1101. Since the answer is in negative, it is storing that negative answer in 2's complement form. So we converted that into the 2's complement form. But here it is displaying that in decimal form. So how it happens means, here I have the complement of 2 is equals to 1111 and 1110. Now in order to convert this into the decimal form, this is what the computer stored, because the computer stored the negative values in 2's complement. So this value is stored in the stored in computer. Then while displaying, it is converting this to the decimal form. So when we convert this 2's complement to the decimal form, that how we can convert means we need to invert all these bits, whatever the bits are there, no, that it will going to invert. So it is I will start from here. Yeah, so 0 0 0 0 and 0 0 0 1. Then we need to I think it is right now 2's complement. It is going to before inverting the bits, just you need to subtract the 1 from this. While showing the computer, what it will do means it will store the result in 2's complement. Then while displaying, that is converting back to the decimal, it will going to subtract 1. Then it will going to invert the bits. Then it will going to that means it will going to add 1. Then it will going to convert that to decimal. Then it will shows us the result. So here it is the value stored in the PC. Now I need to subtract 1 from this. That means it is the process. Easily I will tell one trick how to do all those things. This is the process what is going to happen. Then here this will going to subtract 1 means it is same as 1111 and 1101. Then we need to inverse this bits, that is 0 0 0 0 and 0 0 1 0, and we need to add 1 for this, so it becomes 0 0 0 0 0 0 0 0 and the 1 means 0 0 1 1. Then convert this to here one thing is that here it will negative of convert to decimal. Okay, this is what the 2's complement, because the negative numbers are going to store in the 2's complement, so the result will be minus always. because as I told already, the negative numbers only that will going to store in the 2's complement. Positive number, it will directly go to store in that means the binary format. So here now the result will be, this is the result is 3, but the result is a negative, so minus of 3. Ultimately we got why here it is showing as minus 3. The actually one easy trick is that this operator is there, no, that means the ones complement operator, it is just nothing but a negative of x plus 1. Remember this, okay, x plus 1. Remember this formula, this say easy formula, okay, just remember this, it is negative of x plus 1. Just remember this, because whatever here we are giving, for example I'm going to give the value of a equals to 20, a and 1's complement, okay, a 1's complement, yeah, 1's complement of a, directly I can say this as a minus 21, because you just remember this formula, minus of 20 plus 1 you can see is equals to minus 21. But the process what it will going to store and what it will do, that is that follows this method, okay. But here if we think just like 1's complement, then we can just for example here I'm going to just write okay, 60, a equals to 60, then 1's complement of 60 is minus 61. But we may think that the 1's complement it will going to invert the bits, and yeah, I did some calculations here, notes the 60's binary value, and okay, I will just going to write that the 60's binary value is 0011 and 1100. Okay, this is what the 60's binary value, and it's a 1's complement is 1100 and here 0011. So we may think that it may gives us the decimal form of this number, but I explained why it is going to give minus 61. You may think that this is the 1's complement, so the decimal, that means if we just think of this number, then it is not at all relating to minus 61. But I told how it will going to work and what it will going to process. So simply we can remember this minus of x plus 1. Here if you want to say, then its 2's complement is equals to 11000100. Okay, this is the 2's complement. I calculated, so I am telling. And if we invert this, okay, if we want to minus 1, or yeah, we need to minus 1 from this, same as this method, we need to invert the minus 1 and invert the bits, add 1 and convert it to decimal. Or else simply we are adding here plus 1, because here you can see subtract 1 and add 1. So instead of that, here before converting that to the 2's complement, we can just use this 1101 and 0011. Here only I am going to invert the bits, add 1. Okay, invert the bit means we will get this bit, and yeah, we will get 0011 and 1100, and by adding 1 to this we will get 0011 and 1101. Then convert this to what that we need to convert this to the decimal format. Then we will get 111101. We will just see what it is in decimal format. It is 1111. Okay, yeah, add 1, yeah, 111101. I need to type again 1. Okay, I need to in binary, and we'll type 1111. Is it like 111101? Then we can see it is equal to 61, but it is in negative. Here it is negative because it's the negative number. I think you understand about this. If you get any doubts about this things, then you can just comment this. But for simply, if you just remember this, then we can predict what it will going to give the output. I just explained the what will going to happen inside the computer and all those things. I think you have understand about this this ones complement operator, and I think now we forgot what all the remaining operators are there at this moment. Yeah, what is those remaining operators? It is operators, okay. Ones complement, and the next two is the left shift and the right shift operator. Okay, for example, if I have some numbers like okay, I will going to take those numbers as yeah, for example 9 is equals to 1001. If I do right shift of this, okay, here right shift and the left shift, okay, I will explain how we are going to make the right shift. A equals to 9, okay, equals to 9, okay. Then if we just do the right shift, A is right shifted 1, then we will get the answer as 4. It's because right shift means here we need to shift 1 to the right side. It is the 9 is get converted into the binary, and we need to shift 1. So this will going to this will going to equals to, okay, we need to shift the 1 position. That means here 0 0 1 is here, and yeah, okay, this one is get shifted to this side, so it becomes 1 1. I think yeah, it is the right shifting, so we need to shift 1 to this side. So no, not like that. It is not shifting like by taking this last to the this side. That means it is not going to what's that? It is not looping over that. It is just shifting. So right one shift means it is going to 0 1 0 0. One value we lost because it is not like rotating. We are not rotating here, we are just shifting. So if you think like we are rotating, then that's the wrong. Okay, here we are shifting. So now I shifted one thing to the right, so here you can see the value is 2 power 0, 2 power 1 and 2 power 2, that's 4. That's why it is displaying 4. Okay, here we are not rotating, it is just shifting. Okay, then if we check any other values, for example A equals to 1 0 1, okay, yeah, A equals to 10. Then if I shift A, okay, I will going to shift a right shift of 4 times, then you can see we'll get the 0, because the 10 is 1 0 1 0, and if we shift 4 times 0 0 0 0 1 0 1 0, but this is not that. This already shifted 4 times, so yeah, like right shifted 4 times, so we will get the 0. Similarly, the left shift also going to work at that time. For example, A equals to 9. Okay, yeah, here I need to write A equals to 9. Then if I shift left shift, left shift of 1, it will give us 18, because here if we shift okay, 1, it is 9 is 1 0 0 1, and if we shift left side, then it becomes 1 1 0 0 1 0. I think this is correct now, 1 1 0 0 1 0, because we shifted 1 to the left side. Okay, if I tell right, it's wrong, left side. So now if we check the value of this one, 1 1 0 0 1 0, okay, I will open the calculator, and okay, we will just check the decimal value 1 1. Yeah, this is the binary value 1 1 0 0 1 0. Yeah, it is not, I think 1 1 0 0 1 0. Yeah, 1 is extra added. This is not there. Okay, this 1 is not there. It is just shifted 1 times. So here it is 1 0 0. It is like this. I think you understand now. Yeah, it's like this. Just it is shifted left 1 time. So 1 0 is added. 1 0 0 1 0. So here I need to write 1 0 0. Yeah, 1 0 0 1 0. This equals to, you can see in decimal it's equals to 18. So here I got that as 18. If we shift this one instead of 1 time, if I shift A, left shift 2 times, then you can see it's 36. So here again 1 0 is going to add, because it shifted the 2 times. 2 times it will going to shift the left. I think you have understand about this operators, subtractive, Xor, or this the bitwise operator. So on conclusion, you can see these are all the main types of operators. I think you hope understand completely about these operators. Thank you.